Welcome to Vodcast 2.1, an introduction to matrices. Remember to write down what you see on the slides and what you hear me say, as well as writing down all the examples throughout the video. Let's get started. This is a brief overview of what we'll be covering. Don't worry about the specific terms yet. I just want to give you a brief summary of what will be covered. First, what is a matrix? Second, indicating the dimensions of a matrix. Third, listing the Aij elements of a given matrix. Fourth, the rule of equality of matrices. Fifth, identifying the missing elements of matrices. And sixth, adding and subtracting matrices. Let's get started. First, what is a matrix? I want to go over some quick terms. First, a matrix with the IX at the end is one matrix. If it has I, C, E, S at the end, matrices is more than one matrix. So I just wanted to go over that brief terminology. Here are some examples of matrices. Okay? A matrix is just a rectangular arrangement of entries or elements. Don't let Keanu Reeves tell you any differently. Matrices can be added, subtracted, or multiplied. Notice how I didn't say they could be divided. We will see in a later lesson how the use of matrices is applicable to real-life situations. One other important note about matrices before moving on. When writing matrices, the numbers or elements of the matrix are identified by brackets. So one way that we know that this is a matrix is because of these brackets. All the numbers are contained within the brackets. All right. So, terminology. These are the entries or elements of a matrix. So whatever numbers are inside or variables, there could be variables, these are called entries or elements. Next, let's talk about the rows and columns of a matrix. So the rows, this is row number 1, this is row number 2. So rows run horizontally across, okay? So columns run up and down, so this is column number 1, this is column number 2. Okay, so that's very important. Columns run up and down, rows run across. Okay? So first thing that we're going to do is indicate the dimensions of a matrix. The dimensions of a matrix are indicated by the number of rows by, this X means by, the number of columns. Okay, so if we look at this first one, writing on your computer is not as easy as it looks. Okay, so if we look at the first one, remember our rows go across. So there are 1, 2 rows. So this is going to be a 2 by, we write the X, and then we have the number of columns. So 1, 2. This is a 2 by 2 matrix. Okay? So what's the size of this matrix? Again, we're going to do the number of columns, 1, 2, 3, or the number of rows, I'm sorry. We're going to do the number of rows, 1, 2, and 3, so 3 by, and the number of columns, 1, 2, 3, 3 by 3. So when indicating the size or the dimension of a matrix, we do number of rows by number of columns. So 2 by 2, 3 by 3. Those are the sizes. Notice that they're different. The 2 by 2 and 3 by 3 are different. So here's a couple examples. Take a moment to pause the video here and write down the following matrices in your notes. Next to each matrix, identify the dimension of the matrix. Remember, you're defining the number of rows by the number of columns. Go ahead and pause now. So you should have written down all of these, and now we're going to go over them. Remember, we're doing rows by columns, so 1, 2, 3 rows by 1, 2 columns. This is a 3 by 2 matrix, and we have 1, 2 rows here, and 2 by and 2 columns, so it's a 2 by 2. The next one's a little tricky. We have 1, 2, 3 rows, so it's a 3 by, and there's only one column, so it's a 3 by 1. All right, the next one, 2 rows, 1, 2, so it's a 2 by, and we have 1, 2, 3 columns, so 2 by 3. All right, notice the 2 by 3 and the 3 by 2 look different. So make sure you remember that we're doing rows by columns, okay? Very important to remember. Okay, so listing the A, I, J elements of a given matrix. So Aij just refers to, this is the entry or element in the ith row, and the jth column, okay? So stick with me here. If we have this matrix, okay, this is the first row, okay, and this is the first column. So the variable located in the first row and the first column is 2. First row, first column. So A11 or A11 would be 2. A12 would be the first row, second column. So we have our first row, second column. Okay, so that would be 3. Okay, now this one is the second row, first column. So we have our second row and our first column. That would be 5. This would be second row, second column. That would be the last variable that we have, 4. This is just a way to write which entry or element we are referring to. Remember, it's always rows by columns. Rows by columns. Okay, take a moment to pause the video now and write down the following matrices in your notes. Be sure to indicate the A11 and the A32 for this matrix, which is a 1, 2, 3 by 1, 2, so it's a 3 by 2. And then write down the A11 and the A23 for this matrix, which is a 1, 2 rows by 1, 2, 3 columns, so it's a 2 by 3. So go ahead and pause now. Okay, you should have paused your video and filled in the A11 and A32 for this matrix. Let's go over it. So A11 would be first row, first column. So our first row is here, and our first column is here. So the variable we're looking for is 31. So 31 should have been your A11 for this matrix. A32 would be 1, 2, third row and second column. So 1, 2 columns. So negative 30 should have been your A32 for this matrix. I just want to point out that depending on the matrix, these variables could be different. While they indicate the same place in the matrix, the numbers could be different depending on the matrix. Okay, let's continue on to the next one. We'll see that in the next one, because the A11 for this matrix would be the first row, first column. For this one, it's 16. So A11 is the same entry but different matrix, so it makes it a different number. The A23 would be second column, or second row, rather. Second row, rows are always first. Second row, third column, so 1, 2, 3, that would be 14. So our A23 would be 14 in this case. So check and make sure that you got those correct. Again, rows by columns. All right, so next we're going to do the rule of equality of matrices. In order for matrices to be equal, they must have the same number of elements. Remember, elements are the same as entries, same number of elements or entries, and be the same dimensions. So for example number 1, matrix A has 1, 2, 3, 4 entries. Okay, so that's the same number of elements or entries, and it's a 1, 2, 2 column or 2 rows by 2 columns. Okay, matrix B has 1, 2, 3, 4, 5, 6 entries or elements, and it's a 1, 2 rows by 1, 2, 3 columns, so 2 by 3. Okay, so we know that these matrices cannot be equal because not only do they not have the same number of elements or entries, but they are not the same dimensions. So these cannot be equal. In example number 2, our matrix A has 1, 2, 3, 4, 5, 6 entries, okay? And it has 1, 2, 3 rows and 1, 2 columns. So it's going to be a 3 by 2 matrix. And B has 1, 2, 3, 4, 5, 6 entries as well. So this looks promising because they match in the number of entries. But it's a 1, 2 column or 2 rows, sorry, by 3 columns. Remember, 3 by 2 and 2 by 3 are not the same. So the A cannot equal B in this case. So neither of these are equal because of the conditions set above. Same number of elements or entries and same dimensions. So neither of these examples can be equal.